So I've just gone through expected value, but we're going to keep going. So in this, we're now going to talk about fair game. So when we gamble, which none of us do, the expected gain is the return less the stake or minus the stake. So I've just simplified that down a bit. So the game is fair if the expected gain is 0. So if X represents the gain of a player from each game, the game is fair if the expected value equals 0. So if we were thinking in terms of this, I'm going to use a real life sort of example. If we were dealing with sports bet, most of the time, if two teams have an equal chance of winning, we look at each team has $1.90 odds and you stake $1. So that means that if you bet on both teams, okay, you would spend $2 and only one of those stakes would win, so you'd only win $1.90, so your expected value actually is going to be less. But let's jump down and do an example of this. So we're going to jump back down to the bottom. So we're given this scenario here. So in a game of chance, a player spins a square spinner labelled 1, 2, 3, 4. Now this bit's important. It doesn't say anything about any odd being more likely than another. So we assume these are all equally likely. So we have, just in our scenario, we would expect that the probability of X equals X, and this one up here would be your X value, is going to be 1 quarter, 1 quarter, 1 quarter, 1 quarter. Okay, so I've just put them in there. So the player wins an amount of money according to the table alongside. So we've looked at that table. Work out the expected return. Now this is important. Return is not gain. So we were talking before, and I might not have brought the attention to it. So the expected gain is the expected return minus the stake. So we're working out, at the moment, we're working out expected return. So then we can minus the stake from it. So let's work out the expected return. So if we gamble in this thing, we would expect if we get a 1, we would get $1. So we would expect, I'm going to write here, we're going to pick our variable. So let's go, let y be the expected return. So in this, we're looking at the returns here. So in this set y, the values, so this here is actually y, the winnings, which we're looking at, which is the return. Your y values are actually $1, $2, $5, and $8. And so our next bit here is our expected value of return is going to equal $1, and we had a quarter of a chance happening for that. So that was this top one here. So $1 and a quarter of a chance of spinning a 1. And then we've got plus $2 and a quarter of a chance of that happening too, plus $5 and a quarter of a chance of that happening, plus $8 and a quarter of a chance of that happening as well. Now this is getting a bit messy. I'm going to rub out the dollars here. I've just sort of put them in so we can understand where the numbers come from. So we wouldn't usually put dollars in here. We're actually working out the expected value in that one. And so when we put these all together, we're going to get 1 quarter plus a half plus 5 quarters plus 8 quarters. So this ends up being 1 quarter plus 2 quarters plus 5 quarters. So 1 quarter, 2 quarters, that's going to be 8 quarters, 16 quarters we're going to end up with there. So 16 on 4, which means we end up with $4. Okay, so that's the expected return. So it means anytime we bet on this game, we expect to get $4. Now, the next bit is, it says determine the expected gain of the player from each game. So we're looking at here, let X be the expected gain. So we've changed the variable. So realistically, this would almost be like if we were looking at X. So maybe I shouldn't have put an X here for that one there. But like, I'm going to just remove that. Hopefully you guys watch the video so you don't see that. In this sort of space here, we would be looking at X would be the expected gain of the player from each game. I've actually missed a bit of the question. Gain of the player if it costs $5 to play. Sorry, I forgot that. So if you consider this $5 to play, I'm jumping over here because in this scenario, if you roll a 1, it costs you $5 to play. This is almost like a -4. This one here is like a -3. This would give you a 0, and this one would give you a +3. And looking at those results, if you are staked $5 on each game, you make your money back, you win money, but here you lose. You would expect, just looking at this table, that the expected value isn't very good on this one. And so what we do is we go, well, the expected value of X is going to equal the winnings, the expected winnings we got before, minus $5 to play, which means we're looking at $4 minus $5 equals -$1. Okay, so that's our expected gain from each. This is a gain here. Would we recommend playing this? No. E to the X does not equal 0, so it is not fair. The expected return, not expected return, expected gain, sorry. Expected gain in long term is an average loss of $1 per game. All right, so that would let us, that would tell us that we're going to pretty much lose $1 on every spin. And sometimes if we wanted to work out the expected value, we could also do it this way here. We could have also done, well, a quarter times this, a quarter times this, a quarter times this, and we would have got the same value out. So either or would have got us there. But that's it. Thanks.